araw na ito ay define and illustrate linear indistinguishable permutation of an object and solve problems involving linear indistinguishable permutation. Let us recall that we have three techniques in determining sample space of an event. We have the tree diagram, the listing method, and the fundamental counting principle. Para lalo nyo pang matandaan, I will give you an example. Shaina uses the four letters of her nickname S, H, A, and Y in different order to assign computer login passwords to her 22 students. Each letter appears only once in a password. Question number 1. Are there enough passwords for Shaina's 22 students? Number 2. How many different passwords can Shaina create? Number 3. Explain how to find the number of passwords possible if there are 6 letters available. Observe na gamit ang unang letra ng kanyang pangalan, mayroong 6 na passwords na pwedeng magawa, tulad ng S-H-A-Y, S-H-Y-A, S-A-H-Y, S-A-Y-H, S-Y-H-A, and S-Y-A-H. Gamit naman ang ikalawang letra ng kanyang pangalan, ito ang mga passwords na pwedeng magawa. H-S-E-Y, H-S-Y-A, H-A-S-Y, H-A-Y-S, H-Y-S-A, and H-Y-A-S. Kung gagamitin naman ang ikatlong letra ng kanyang pangalan bilang pasimula ng mga passwords, ito ang pwedeng magawa. A-S-H-Y, A-S-Y-H, A-H-S-Y, A-H-Y-S, A-Y-S-H, and A-Y-H-S. At kung gagamitin naman ang huling letra ng kanyang nickname, ito ang mga passwords na pwedeng magawa. Y-S-H-A, Y-S-A-H, Y-H-S-A, Y-H-A-S, Y-A-S-H, Y-A-H-S. Kung ating babalikan, sa bawat letra ay may tiga-6 na passwords na nagawa, makahulugang mayroong 24 na passwords na nabuo gamit ang 4 na letra ng kanyang pangalan. Kung gagamitin natin ang fundamental counting principle at sinabi dong hindi pwedeng may maulit na letra sa isang password, we can solve this using 4 times 3 times 2 times 1, which is equal to 24. Bakit tayo gumamit ng 4 times 3 times 2 times 1 sa fundamental counting principle? Meron tayong 4 na letters, di ba? Sa unang letter ng password, meron tayong 4 na pwedeng pagpilian. Sa ikalawang letter ng password, since na nagamit na natin yung isa sa unang letter, meron na lang tayong 3 pwedeng pamilian. Sa ikatlong letter ng password, since na nagamit na natin yung 2 letter, meron na lamang tayong 2 pwedeng pamilian. At sa huling letter ng password, iisa na lang po yung natitira. That's why we have 4 times 3 times 2 times 1, which is equal to 24. Balikan natin yung mga tanong kanina. Unang tanong, are there enough passwords for Shaina's 22 students? So, di ba ang sagot yan is yes. Kasi nga, di ba, we have 24 passwords available. Pangalawang tanong, how many different passwords can Shaina create? So, that is 24. Last question, explain how to find the number of passwords possible if there are 6 letters available. So, we can get the number of possible passwords if there are 6 different letters available through this. We have 6 times 5 times 4 times 3 times 2 times 1, which is equal to 720. Ang tanong, willing ba kayong gumamit ng tree diagram at listing method para lang malaman ang number of possible passwords if there are 6 letters available? Sigurado ako na ang mga sagot ninyo ay may mga ganito sa dulo. Ano ngang tawag dyan? In English, it is called an exclamation point. Exclamation marks were originally called the note of admiration, exaggeration. They are still to this day used to express excitement. They are also used to express surprise, astonishment, or any other such strong emotion. Any exclamatory sentence can be properly followed by an exclamation mark to add additional emphasis. In Filipino, it is read as tandang padamdam, bantas na tumutulong upang maiparamdam sa mambabasa ang isang masidhing damdamin. Sa mathematics naman, mathematicians use an exclamation point to indicate the product by writing n factorial. This is read as factorial. Ano nga basa? Factorial. So, the exclamation point is the factorial symbol. In mathematics, the symbol represents the factorial operation. The expression n factorial means the product of the integers from 1 to n. 4 factorial is 4 times 3 times 2 times 1, which is equal to 24. And 0 factorial is defined as 1, which is a neutral element in multiplication, not multiplied by anything. Saan nga ba natin gagamitin yung factorial na yan? So, ang topic natin ngayon ay about sa permutation. Kapag sinabi nating permutation, an arrangement of objects or events similar to activity in which the order is important. Permutation is an arrangement of things in a definite order or the ordered arrangement of distinguishable objects without allowing repetitions among the objects. Take note of this ha, sabi, without allowing repetitions among the objects. In general, if n is a positive integer, then n factorial is the product of all integers less than or equal to n. So kapag binigyan tayo ng n factorial, that is equal to n times the quantity of n minus 1 times the quantity of n minus 2 hanggang sa makarating tayo sa 2 times 1. Meron tayong special case kapag nakakita kayo ng 0 factorial that is equal to 1. Try nga natin itong isolve. Number 1 is 7 factorial. Number 2 is 8 factorial divided by 6 factorial. Number 3 is 4 factorial times 5 factorial. 1. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1, which is equal to 5040. Number 2, 8 factorial divided by 6 factorial is 8 times 7 times 6 factorial over 6 factorial. Bakit ako nag-stop sa 6 factorial? Kasi po meron na tayong divisor na 6 factorial, so we have 6 factorial divided by 6 factorial is already 1. That's why we have 8 times 7, which is equal to 56. Number 3, 4 factorial times 5 factorial is 4 times 3 times 2 times 1 and 5 times 4 times 3 times 2 times 1. So that will be 4 factorial is 24 and 5 factorial is 120. 24 times 120 is equal to 2,880. So 4 factorial times 5 factorial is equal to 2,880. Paano kapag ganito yung tanong? Find the number of permutations of the letters of the word Mississippi. Pansinin ninyo na maraming letters ang nauulit. Yan ay belong sa distinguishable permutation. So the number of distinguishable permutations P of n objects where P objects are alike, Q objects are alike, R objects are alike, and so on is P is equal to n factorial over P factorial, Q factorial, R factorial, and so on. Para makuha natin kung ano yung n, bibilangin lang natin kung ilang letters yung binigay na word. So, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Meron tayong 11 letters para sa word na binigay. So, n is equal to 11 factorial. Sunod natin gagawin, aalamin natin kung ilang beses na ulit ang bawat letter. So, yung M, isang beses lang. Yung I, 4 na beses. Yung S, 4 na beses. At yung P ay 2 beses. Substitute na natin. That will be 11 factorial over 1 factorial, 4 factorial, 4 factorial, 2 factorial. And that will be 110 times 63 times 5, which is equal to 34,650. May natututunan ba kayo? Sige nga, try nyo nga to. Letter A, 6 factorial times 5 factorial. Letter B, 10 factorial over 4 factorial, 3 factorial. Letter C, find the number of permutations of the letters of the word statistics. is an arrangement of things in a definite order or the ordered arrangement of distinguishable objects without allowing repetitions among the objects. In how many ways can 5 people arrange themselves in a row for picture taking? So that will be 5 factorial, which is equal to 5 times 4 times 3 times 2 times 1, which is equal to 120. Kayo naman ang sasagot. Isipin nyo na lang quizzer kayo ng math. And under time pressure kayo. Kasi yung easy, 15 seconds lang. Yung average, 30 seconds. And yung difficult is 1 minute. Good luck! Solve 4 factorial. Answer 24. Solve 4 factorial plus 5 factorial. Answer 144. Solve 5 factorial divided by 2 factorial. Answer 60. Find the number of distinguishable permutation in the word mathematics. Find the number of distinguishable permutation in the word geometry. How many ways can 4 red flags, 3 blue flags, and 2 white flags be arranged on a line? There are 10 chairs in a row. In how many ways can 5 students be seated in consecutive chairs? Kuyong, kay Ma'am Irma Guevara, kay Ma'am Ligaya Coral, kay Ma'am Beng, kay Ma'am Janina, at kay Ma'am Leone Rose, at sa iba pang mga subscribers ng aming channel. Maraming salamat po